Dear friends, air conditioning engineers, MEP engineers, and consultants, and my dear students, welcome back to VK Jain Sir ki MEP classes. This current module we are discussing vapor absorption type HVAC system in contrast to vapor compression type system we normally use and people understand it by air conditioning. Friends, our current subject is vapor absorption type HVAC system. Vapor absorption type is HVAC system imply uh, lithium bromide type absorption chiller or aqua ammonia vapor absorption system or ammonia vapor absorption machines. Vapor absorption type HVAC system, also known as vapor absorption machines (VAM), are cooling systems that use heat energy from steam, hot water, or combustion rather than electrical mechanical energy to drive the cooling cycle, replacing the compressor with an absorber and generator. These systems typically use ammonia water or lithium bromide water, offering high efficiency, especially when utilizing waste heat, making them ideal for industrial cooling air conditioning systems. Friends, now we discuss the key components of uh, vapor absorption system and its working principle simultaneously. Unlike vapor compression system we normally use, which use mechanical compressors, vapor absorption system use a thermal process to produce cooling, and the main advantage is the system is having no noise except for few motors. Uh, the main component of this can be taken as evaporator, in which the refrigerant, water or ammonia evaporates, creating a cooling effect. Second is absorber. A low pressure vapor is absorbed by a solution of lithium bromide or water. Next component is generator. Heat applies to the mixture, separating the refrigerant from the absorbent, which is then condensed. Now, next is condenser. The high pressure vapor from generator condenses back into liquid. Then there may be few pumps. This component moves the strong refrigerant absorbent solution from the absorber to generator. Now some more information on vapor absorption systems. The principle of water absorption was first discovered by Michael Faraday in 1824 while performing a set of experiments to liquefy certain gases. Another French scientist, Ferdinand Carré, developed the first absorption refrigeration system in year 1860. Think of, and now single unit as large as 1200 kilowatt, approximately 3,500 tons. Working on this system have been already installed. It was noticed that some liquids have a great affinity for absorbing large quantity of certain vapors and thus liquefying them. The rate of absorption of ammonia is inversely proportional to temperature. Vapor absorption is almost similar to vapor compression system except for the method of compressing the refrigerant. Types of vapor absorption system. Friends, common, they employ a pair of refrigerant and absorbent. First one and most famous is lithium bromide and water, often used for water chilling in air conditioning applications, temperature above freezing. Friends, I came to know about lithium bromide type of vapor absorption system in two different places, and one of them is AIMS New Delhi, and another place where I could see this is in Delhi. uh, I will tell you a little later. The second one is ammonia and water combination, common for low temperature application. This one. Of course, I was telling lithium bromide I have seen at AIMS Delhi and uh, Apollo Hospital, New Delhi, and otherwise at a different place like Chennai. Friends, now we shall be discussing advantages and disadvantages of using vapor absorption systems. First, let me take advantage. Uh, they have quiet operation, no running part as such, no noise except for running of some uh, motor. Energy efficiency, highly efficient for locations with cheap or free waste heat, such as factories, power plants, and hospitals. Now, they are environmental friendly as they use natural refrigerants, avoiding the use of ozone depleting substances. Next is low maintenance. They have fewer moving parts than conventional HVAC system, leading to quieter operation. Applications ideal for industrial cooling systems, large commercial building, air conditioning, thermal plant, waste heat recovery, and other applications that require heating and cooling. Friends, I could see this in Apollo Hospital where 50% and as well as in AIMS Delhi where 50% of the total air conditioning capacity comes from vapor absorption system in comparison to 50 another 50% from vapor compression system. So they take advantage of both type of system. Friends, I have shown a schematic diagram of vapor absorption system at the bottom of this slide. Now we can start from in vapor absorption system, compressor is substituted with an absorber, generator and mechanical pump. This is generator and this is absorber and this is and in between is the pump, this one, this one, sorry. Now These three elements, that means absorber, generator and mechanical pump, absorber and generator. These form the portion like compressor in vapor compression system. These three elements of vapor absorption system are used to compress the refrigerant. Thus, absorption system uses physiochemical process instead of purely mechanical process of vapor compression system. So we complete here. This is absorber from where the mix of strong aqua amino at high pressure is taken to generator, and in generator electrical heating is adopted, and from there both high pressure ammonia vapor is taken to cooling for the cooling portion of the condenser at 35 degrees Celsius, and from condenser the vapor comes, that is cold high pressure ammonia vapor plus liquid comes to the expansion valve where the pressure change happens, and then it goes to evaporator where the cooling effect comes, refrigerant effect. So this complete cycle is like this. From evaporator, refrigerant effect is achieved, and the refrigerant is cooling the enclosed atmosphere, and from there it goes to the compressor system, as it happens in vapor compression system also. And the compression system involves three components. Uh, at first is a pump working to 10 bars, then aqua ammonia solution and generator. These three takes the form of compressor of vapor compressor system. And from this it comes to condenser, and from condenser the high pressure is reduced to from 10 bar to 3 bar, and the liquid and low pressure liquid ammonia comes to evaporator where the heat exchange takes place in evaporator. So this is parallel to cooling coil of vapor compression system. Friends, we have already discussed this in previous slide. This is slightly bigger. Friends, this is on aqua ammonia vapor absorption system. Instead, compressing the low pressure of refrigerant, in the case of refrigerant ammonia NH3 is first absorbed in the water, or more precisely weak solution of ammonia in water, existing in the absorber which is at low pressure and low temperature. Low temperature of about 30 to 37 degrees Celsius is kept in the absorber as water has got more absorbing capacity at lesser temperatures. This absorber converts the weak solution of aqua ammonia coming from generator into strong solution. This absorber converts the weak solution of aqua ammonia coming from generator into strong solution of aqua ammonia by sucking ammonia from evaporator. Initial absorption of ammonia lowers the pressure in absorber, due to which more and more ammonia is sucked into absorber from the evaporator. This makes very strong solution of aqua ammonia. Now this is to be continued. High pressure condensed ammonia coming out of the condenser is passed through expansion valve to evaporator for reducing the pressure of vapor. In evaporator, it absorbs the heat from surrounding air or water to be chilled or cooled. The dry ammonia gas vapor is then allowed to mix with the weak solution of ammonia getting sprayed in the absorber. This completes the refrigeration cycle. Friends, this particular diagram shows you ammonia vapor absorption machine, which had been we had been discussing in past few slides. Friends, now we are comparing, uh, that means bringing out the difference between vapor compressor, which we normally use, and absorption system, which we use in very few cases. In case of compression system, is given in this first column, and absorption system described in second column. So in case of compression system, small systems are compact and large systems are large. In case of absorption system, small systems are large and great systems are compact. In case of compression system, liquid at the exit of evaporator might damage compressor. In case of absorption system, existence of liquid and evaporator exist is not a serious difficulty. About COP, in case of compression, extremely responsive to evaporator temperatures. In case of absorption system, performance not extremely sensitive to evaporator temperature. Now, performance in case of compression system is susceptible to evaporator superheat, whereas in case of absorption system, evaporator superheat is not very important. Now, in case of compression system, COP decreases considerably at part load. In case of absorption system, COP does not decrease extensively by load. Next, in case of compression system, there is a heavy noise in the plant room and vibration also, which may be passed upon to structure if not properly uh, um, uh, treated. In case of absorption system, there is no noise and vibration. Next, as regard maintenance in case of compressor, usual maintenance is required. In case of absorption systems, extremely low maintenance required. Next is various moving parts in the compression system. In vapor absorption, not many moving parts.